Okay, problem 89 says the function f is continuous on the interval from -2 to 2, and if you plug -2 in or 2 into the function, you get 0 out both times. It says if there's no constant value c between -2 and 2, for which the derivative or slope of the tangent line is 0, which of the following statements must be true? So the theory that they're checking here is the mean value theorem. It's actually a special case of the mean value theorem called Rolle's theorem, but if you understand mean value theorem, you should be fine. So the mean value theorem says if a function f is continuous and differentiable, on an interval, then there exists at least one value c that lives in that interval such that the slope of the tangent line at that value is equal to the average rate of change on the interval. And so let me draw a picture as to what this looks like, and then we'll talk about what that has to do with this problem. So this basically looks like this. If you have a function that's smooth and continuous, so continuous meaning, no discontinuities, and then differentiable meaning no corners or cusps or vertical asymptotes. So all the way from A to B, you have a smooth continuous function. Then the f of b minus f of a over b minus a, that would be the slope of the secant line from endpoint to endpoint. And then f prime of c would be basically saying that there's at least one place. In this picture, there's two. So like you'd kind of have like a C1 and a C2 in this picture. But if your graph is continuous and differentiable, then you're guaranteed to have at least one place where the instantaneous rate matches the average rate. So that's the mean value theorem. And then this problem is checking to see kind of your understanding of this theory over here. So let's process what this problem is saying. So this problem is saying that you have a function, you know that when you plug in -2, you get 0 out, and you know when you plug in +2, you get 0 out. And then they told you the graph is continuous, so there's no picking up your writing utensil when you draw it all the way from -2 to 2. But they're saying there's no place between -2 and 2 for which the slope of the tangent line is 0. So what that would mean essentially is that you probably have like, a cusp or a corner happening somewhere in there. Because otherwise, if it was differentiable, it would be smooth, and you'd have at least one place where the derivative is 0. So that means there must be a place where your graph isn't continuous somewhere on the interval. So for that reason, option E would make the most sense. It says for some value k, which I was using the letter C, but you can call it whatever you want. For some value k between -2 and 2, the derivative does not exist. So this picture that I drew you here, where you kind of have a corner, let me take off the one. This corner right here, this would be like the k value there. And so hopefully that makes sense, that your graph would, if it was definitely continuous, which they said it was, it would have to not be differentiable somewhere in order for this theory to not work out.